we will be talking about the third topic called User Datagram Protocol. In our last two classes, we were talking about the transport layer services as well as the multiplexing and demultiplexing and the types of multiplexing and demultiplexing. So during the discussion of services, we try to understand that transport layer uses two types of protocols. And the type of service expected is a reliable, secured, and connection oriented. It would be using a protocol called transmission control protocol. When it requires an unreliable or just a simple connectionless transport protocol with a minimum delay, then it would be using a protocol called User Datagram Protocol. So let us begin our discussion with the User Datagram Protocol. So User Datagram Protocol is basically a no-frills bare bones internet transport protocols. Now what it means, what do we mean by these terms called no-frills bare bones? It's something like a simple extension of your internet protocol. It's a best effort service, and in this case of User Datagram Protocol, your segments may be lost or it will be delivered out of order to the application. The reason is simple. UDP is a connectionless protocol. So different segments travel through different paths. So there is a possibility that some of the segments may be lost or they may be delivered out of order. Then, as we mentioned, user datagram protocol is a connectionless protocol. So what happens when it is a connectionless is here when a UDP sender would like to send the data to the UDP receiver, there is no need of handshaking between the sender and receiver. They can directly send the data from the sender to the receiver. So no connection establishment and connection release phases in case of user datagram protocol. And each user datagram protocol segment, as we mentioned earlier, the data unit in transport layer will be referred as segment, and each UDP segment will be handled independent of others. Where do we generally would like to use this connectionless transport layer protocol called user datagram protocol? It will be mainly used in streaming multimedia applications. So what do you mean by this? So these are the applications in which you want to transmit data in the real time with a minimum delay. There is an acceptance that maybe a packet's lost, but you don't want any delay in the transmission. So they are loss tolerant, means you can find some packets can be lost, and rate is also sensitive, but delay is to be minimized. And in the domain name services, you find the usage of user datagram protocol, and in simple network management protocol also you will find the service of user datagram protocol. Sir, you have been mentioning that user datagram protocol is unreliable. So in case if we want a reliability in this case, then we have to add that reliability requirement at application layer. At the same time, you can also have some application specific error recovery mechanisms in case of your UDP. Okay, so no frills bare bones. It's something like it's the best of a delivery service. It would try to send the data to the best. There is a probability of loss of packet or out of order, and no handshaking mechanisms. Every packet treated independent and will be suitable for applications like multimedia, DNS, and SNMP. Now, what does the UDP segment basically comprise of? As we said, the data content in transport layer is referred as segment, which means the data it receives from the network application layer and adds an header to it. So this will be referred as a segment. What does a segment basically consist of? First, a segment consists of the header part, followed by the data part, which it is receiving from the application layer. Now, what are the contents of our UDP segment header? As we mentioned earlier, the UDP segment header, we will be having 4 fields, each of length 16 bits, which is nothing but 2 bytes. So there are totally 4 fields, each of length 2 bytes or 16 bits. What are the 4 fields we have? The first field is called as source port. The source port refers to the port number of the source which is actually trying to communicate. So for instance, we are talking about a client and a server. Then the client's port number will be referred as the source port address, the port which is actually generating the data. The port address of the receiver to whom the data is being planned to be sent, we refer it as a destination port. As we mentioned in our previous sessions, the length of port address is 16 bytes or 2 bytes. And next, the third field which we have is called as the length field, which is trying to indicate the total length in bytes of the UDP segment, including the header. So including the header and the data field, what is the length of the data will be expressed in UDP length field. And the last field in your UDP segment is checksum. Let me tell you one important point. In UDP, you don't have any flow control. We don't have any congestion control, but we implement error control mechanism using a checksum concept. So we have already discussed how do we implement checksum in data link layer. Here we will once again try to recollect using a simple example. Along with the 4 fields of header of UDP segment, we will also try to transmit the application data which it has received from the application layer. So few key points on why the particular UDP is being preferred is first, no connection establishment is required. So whenever you would like to have a data transmission, you can do it immediately without any delay. It's a simple, as the complexity is less in terms of connection establishment. The header size is definitely less. The total length of the header, only header is 32 plus 32, 64 bytes or 8 bytes. So 4 fields, each of 2 byte length. And as mentioned earlier, there is no congestion control or flow control mechanisms in UDP. UDP can blast away as fast as desired. So all these are the features of UDP that made it to be one of the alternatives of using a transport layer protocol to that of TCP. As we mentioned in the previous slide, that error control is implemented in UDP using a concept called checksum. So we people have been learned about checksum in our data link layer. Let us try to learn and understand this once again. So to detect the errors, that is the flipped bits, in case of error 0 has changed to 1 or 1 might have changed to 0. So that has to be identified and rectified. For that reason, we will try to use the error control techniques like checksum. So here, what is the thing to be done is, in our UDP segment, all the contents, including the header fields, are taken as a sequence of 16-bit integers. So what do you mean by it is, all the contents will be expressed as a 16-bit integers. Then to calculate the checksum of the contents, what we do is we do the addition in one's complement sum of the segment contents. And once complement sum of all this, the sender puts this checksum value into UDP checksum field. So whatever the checksum that we get here, we'll be trying to keep it field. Now this is at the sender side. So here we are calculating the checksum value by taking all the contents as a sequence of 16-byte integers and then put that particular checksum value into the UDP segment. Now the receiver compute checksum of the received segment, and this receiver checksum is value is compared with the checksum that is contained in the segment checksum compared with the checksum value in your UDP segment. In case if both the values are not equal, what the checksum we calculated at the receiver is not the same as the checksum which is included in the segment of the UDP, then an error is detected. In case if the both values are same, then no error is detected. So what we need to understand here is how do we calculate the checksum value. As we mentioned, all the contents of the UDP segment has to be mentioned as a multiple or a sequence of 16-bit integers. Let us try to find out how do we calculate a checksum using two 16-bit integers? For instance, these are my two 16-bit numbers like source port and destination port. So these are my source port and destination port, and just give me a minute. And we are trying to express the source port number and destination port number as two 16-bit integers. Now what is the rule to do the ones complement addition is, first we have to calculate the modulo 1 addition. So what do we do here is simple. The rule for implementing checksum calculation, 1 plus 0 is 1. And first 0 plus 0 is 0. Then 0 plus 1 is also 1. And the last one, 1 plus 1 is 0 with carry 1. And one more important thing which we may require is 1 plus 1 plus 1, which is nothing but sum is 1 with a carry 1. So these are the rules of addition which we have to use. And when we are implementing ones complement addition, whenever a carry is generated, that carry has to be wrapped around. So what we mean by wrap around concept is the one which is being generated as the carry at the beginning has to be added to the least significant bit of the sum. Before that, let us first do the addition using the rules which are mentioned here. So 0 plus 1, 1, 1 plus 0 is 1, 1 plus 1, 0 with carry 1, 0 plus 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with the carry 1, 0 plus 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with a carry 1, 0 plus 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, 0 with a carry 1. Now here we have 3 ones. So their addition will result in sum of 1 with a carry 1. When you are doing a ones complement addition, whenever a carry is generated from this addition, this has to be wrapped around. So they have to be added to the least significant bit. So move this one to the least significant bit position and once again do the addition. Now 1 plus 1 is 0 with a carry 1. Then 1 plus 1 is 0 with a carry 1. Then 0 plus 1 is 1. 1 plus 0 is 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, and again 1. And this is the sum value. Now in this case, when you are doing ones complement addition and the sum is not generating a carry, it means it is in the complement form. So to get the final value, what should be done is the obtained sum, we have to calculate its ones complement value. How do we get a ones complement value? Simply replace 1 with 0 and zeros with 1. You're going to get the ones complement value, which is nothing but the checksum. So what the sum we have got here is 1. So we start from the LSB and we'll be calculating the complement of that sum. So 0 becomes 1, 0 becomes 1, 1 becomes 0, 0, 1 becomes 0, 1 becomes 0, 0 becomes 1, 1 becomes 0, 1's complement 0, 1's complement is 0, 0 complement 1, 1 complement 0, 1 complement 0, 1 complement is 0, 0 complement is 1, and 1 complement is 0. So this final value which we have got is called as the checksum value. So while we are sending these two numbers along with the source port and destination port, we also need to send checksum value in case of checksum error control technique. So what we have to exactly do is take two 16-bit integers, then implement ones complement addition, which means we have to do the modulo 1 addition, and whenever a carry is generated, that has to be wrapped around. In case if there is no carry, it indicates the sum is in the complement form, so we have to determine its ones complement so that we get the final value. So with this is how we calculate the checksum. UDP checksum, as we mentioned, is computed as follows. Checksum is 16-bit ones complement of the ones complement sum of the pseudo header of information from the IP header, UDP header, the data which is padded with 0 octets at the end. So what do you mean by it is, for instance, I have a value like 30, which will be generally expressed as 16, 8, 4, and 2. It's only represented in 5 bits, but we have to represent all the numbers in 2 octets, that is 16 bits. So what we have to do is, before this value, we have to append the 11 zeros so that the length of this value is also 6, 7, 8, 9, 10, and 11. Now it is also 16 bit. So this is how we'll try to calculate the UDP checksum. As we mentioned, there are a number of applications in which we use user datagram protocol. As we have the alternative called transmission control protocol, let us have a quick glimpse on what are the applications in which we use UDP, what are the applications in which we prefer TCP, and what are the applications where we can use both UDP and TCP. Coming to the applications like electronic mail, where you use a protocol like simple mail transfer protocol, for remote logging using telnet, for web using HTTP, or for file transfer protocol we use a protocol like FTP. It is supported with the transport layer protocol like TCP. So for these applications we prefer TCP. But for applications like streaming, multimedia, and internet telephony, we can have UDP or TCP. And for remaining case applications like network management, SNMP, or DNS, as we mentioned, or routing information protocol, the popularly used transport layer protocol is UDP. So we have an option between TCP and UDP, and which one has to be used depends on the particular application for which we have been using. If we want a minimum delay, we are going to prefer with our UDP. If we want, before we move ahead to the connection oriented transmission control protocol, we would like to understand a topic called principles of reliable data transfer. So one of the important functions which a transport layer is expected is to provide a reliable data transfer to the application layer. How do we provide that? We will be discussed in our principles of reliable data transfer, and then we will try to discuss about the connection oriented transmission control protocol. So let us start our discussion about the principles of reliable data transfer and how do we provide that in transfer layer. Right. So as we have discussed, one of the important functions of the transport layer is to provide reliability to the application layer. So your application layer is trying to transmit data through the transport layer, and it is expected that transport layer provides reliable data transfer to the application layer. But in reality, the transport layer is transmitting the data to the next layer called network layer, which is basically an unreliable channel as it's in best effort delivery. But however, we are able to understand with the help of the services provided by network layers, still our transport layer is providing a reliable data transfer to its application layer. So the provided service is reliable data transfer, but in reality, the transport layer is once again taking the service of network layer, which is actually an unreliable channel. So let us try to understand how this transport layer is providing that reliable data transfer. We are going to refer the reliable data transfer term in this particular topic as RDT. Right. So there are certain set of operations which are involved in case of the reliable data transfer protocol. Now let us look at one after the other. What are the set of operations required? The first we will try to understand that we are going to use a command called the reliable data transfer send. And what is this particular command is, as we know that the role of transport layer is to receive the data from the application layer, and once it receives the data it has to add its header to the contents of application layer and make it as a segment. So reliable data transfer send is called from above, and whenever the data is passed to the transport layer it has to be delivered to the receiver's upper layer. So reliable data transfer command is all about receiving an instruction from the receiving the data from the application layer and then transmitting it to the receiver. Now the transport layer forwards this data to the network layer of the sender side. So here, as we know, the network layer is providing unreliable data transfer. We are referring that unreliable data transfer as UDT, and your network layer is basically providing unreliable data transfer. And once it receives the segment from the transport layer, it is going to convert the data into packets and then send the data to its bottom layers. So what is the job of the network layer is to receive the data from the transport layer, convert the data into packets, and then try to send that data through an unreliable channels. This is the second function which we are using. So transport layer uses reliable data transfer send, and the network layer of the sender will be using unreliable data send. Now the receiver side, the network layer will receive the packet which is delivered by the sender, and we term this as RDT receive. And in this data which is received, the packet consists of header plus the segment information. So what we try to do is we try to remove the header information and we'll try to forward the segment information to the transport layer. So whenever the receiver side network layer receives a packet, it tries to extract the data from the packet by separating the header from the data segment. So here we could find, so once we receive the packet, we'll try to extract the data and try to deliver the data, and the data which is received by the transport layer will be forwarded to its application layer. So totally we are going to use 4 commands in our reliable data transfer. What are that? Reliable data transfer send, unreliable data transfer send, reliable data transfer receive, and deliver the data. We'll try to understand the concept of reliable data transfer a bit with an increasing complexity. First, let us start with incrementally developed sender and receiver sides of the reliable data transfer. First case, we are going to transmit only a unidirectional data transfer. So it means the data will flow in one direction, but the control info will flow in the both directions. What it means is the data will be flowing from one side to the other, but in the other side you may have an acknowledgement or negative acknowledgement. So since you can find both the device direction, it's still bidirectional, but data is only flowing in one direction. And to understand the reliable data transfer, what we are doing is we are going to use the finite state machine concept that is used to specify your sender and receiver. As we know, a finite state machine is the one which is going to have a limited or a finite number of states. In our first scenario, where the data is unidirectional, we are going to consider 2 states. The state 1 is used for the sender, and the state 2 is used for the receiver. So both sender and receiver are going to have one state, and they will have a movement from one state to other depending on the event that is occurred. And the next thing is whenever an event occurs, a certain set of actions is to be taken. If no action is to be taken, we use with a symbol called cap. So just remember, we have the 2 things. One is the event. Next, the action to be taken whenever an event has to be occurred. So in the first scenario, when there is only one unidirectional data transmission, the sender will have only one finite state and the receiver will have one finite state. Next, the case one, as we mentioned, it's an underlying channel, perfectly reliable. So what do you mean by a perfectly reliable? Means all the data which is going to be transmitted is going to be transmitted without any error. And second thing is there will be no loss of packets. So whatever that we are going to transmit will be transmitted without any loss. So we have a separate finite state for sender and a separate finite state for the receiver. So what do we do here is the sender sends data into an underlying channel. So what exactly the sender role is? It is waiting to receive the data from the application layer, and once the transport layer of the sender receives the data from application layer, it has to do the reliable data transfer send. To whom the reliable data transfer send has to be made? It has to be made to the network layer of it. And what does the network layer does is it receives the data from the transport layer, that makes a packet from that data which it receives from the transport layer, and once it has made the packet, it will try to send that through an unreliable channel, which is unreliable data transfer send. So this is your step one, and then we'll have your second step, which is UDT send. Now at the receiver side, your receiver is initially waiting to receive the data from the sender end. Once it receives the packet from the unreliable channel, then that particular packet is received by the receiver, and since we have assumed that there is no bit error, this packet will be forwarded to the upper layer, which is nothing but transport layer, and before that it will try to extract the data, and the data will be delivered to the upper layers. So totally we have four stages: reliable data transfer send, then unreliable data transfer send, reliable data transfer receive, and finally the extract and deliver the data. So this is the case where every data which is transmitted by the sender will be able to be received by the receiver without any error, and also there is no loss of packets. So it's an ideal or an ideal kind of perfect channel. It's a simple like a simplex protocol where every data which is sent by the sender will be received by the receiver without any loss or without any errors.